Okay, so now that we've introduced vector valued functions, now we're ready to talk about taking derivatives of vector valued functions. So given a vector valued function, say written out like this, since x of t is just a function of a single variable, y of t is a function of a single variable, and z of t is a function of a single variable. If each of them are separately differentiable, then the vector value function taken together is also differentiable. And basically, to calculate the derivative, you just individually take the derivative of each component separately. So for example, in example 1, we're given this vector valued function where the first component is the function sine of t squared, the second component is e to the cosine t, and the third component is t times natural log of t. So taking a look at the first two components here, we have a composition of functions, right, because the t squared is sitting inside the sine function, and here the cosine is sitting inside the exponential function. So these two, because they're composition of functions, are going to require the chain rule. So let's try to remember how the chain rule goes. Right, so if I want to differentiate some composition, say f of g of t, right, so here the inside function is g, the outside function is f, then the chain rule formula is f prime, where the g stays the same, times g prime of t. Okay, so let's start taking derivatives, right? So as we mentioned previously, so for a vector valued function, you think of the x, y, and z components separately, and then we take the derivative of each of them separately, right? So let's first take a look at x prime, right? So I need to differentiate x, which is sine of t squared. So this is a composition of functions, right? So we have the outside function and the inside function, right? So sine is playing the role of the outside function, and the t squared is playing the role of the inside function. Okay, so now let's differentiate, right? So the derivative of sine is cosine, right? So that's the f prime part here, right? So the derivative of f, derivative of sine is cosine, and then here this is just g without the prime, so that means that the g stays the same, right? So inside the cosine function, the t squared stays the same, right? So that's this part of the chain rule formula, and then times g prime, so the derivative of g, what is the derivative of t squared? That's just 2t. Okay, so this is the chain rule formula, right? So let me write it out again so you can see exactly the different parts, right? So the cosine was f prime, right? So then inside the f prime, the g stays the same, right? So that was the t squared, and then times g prime. Okay, so that's x prime. And then now we repeat the same thing for y prime, right? So I need to differentiate e to the cosine t, right? So this is a composition of functions again, right? So the e is the f, and the cosine t is the g. So again, we apply the chain rule formula. So f prime is the exponential function. The derivative of the exponential function is still the exponential function. And then inside, the g stays the same. So the inside is part of the exponent, right? So the cosine is in the exponent and it stays the same. And then times the derivative of cosine is minus sine. Okay, so that's the chain rule for this. And then when I take the derivative of z, it's t times natural log of t. So this is a product. So we're going to need the product rule. So let's quickly remember the product rule. Right, so the derivative of, say, f times g is f prime times g plus g prime times f. Okay, so with that in mind, let's take the derivative of z, right? So it's t times natural log of t, right? So t is the f, natural log of t is the g. So what is the derivative of t? That's just 1. And then g stays the same, so natural log stays the same, plus g prime, so the derivative of the natural log is 1 over t. And then times f stays the same, so that's just t. Okay, so these are all the derivatives. And then finally, we can put it together into a vector form. So r prime is the vector with each of these functions as the components, right? So this, let's just simplify this. So we have 2t times cosine of t squared. That's the first component. What about the y component? That was minus sine t times e to the cosine t. That's the y component, and then the z component was this derivative. So that's natural log of t plus, and here the t's cancel out, so that's just 1. Okay, so that's r prime of t. And again, let me just label it again real quick so we see how everything is set up, right? So this was x prime, this was y prime, and this was z prime. Okay, so that's the derivative of a vector valued function.